Welcome back. In the past two lectures, we have looked at some direct incentives to increase electrical vehicle adoption. In the coming two lectures, we'll have a look at how innovation can help to create a more positive business case for electric vehicles. Especially, we'll look at the vehicle-to-grid concept. Let us first introduce the motivation behind this concept. At the same time as for the transportation sector, a shift from fossil fuels to sustainable, renewable energy accounts also for the energy sector. The current transportation system roughly accounts for a quarter of the total consumption of fossil fuels. To achieve the energy goals for 2050 and beyond, radical changes are needed. Energy and transport sector are more and more interwoven. Therefore, we talk about sector coupling. Both sectors have not only similar goals, but they do need each other to achieve the environmental goals. Decarbonization requires innovation within the entire system, innovative mobility solutions not only designed for transportation, but also to support the operation of energy systems. In the transition towards low-carbon electricity systems, the increasing variable renewable energy sources are calling for more flexibility in the whole electricity system to cope with the uncertainty and variability that affects the residual demand. This means that flexibility is needed in the situations when there is a surplus in production. In situations where electricity generation, for example, from solar and wind, is higher than the usage at some moments in time, or a shortage of energy, demand is higher than the generation. Normally, this flexibility can be offered by traditional players through, among others, energy storage and demand response. Demand response concerns defining and using mechanisms that enable energy customers to reduce or to shift electricity usage during periods of peak demand. The flexibility need of the electricity systems provide also opportunities for new players from different sectors. With the continued electric vehicles adoption, the potential aggregator capacity of the cars can also be exploited in the electricity markets. While plug-in electric vehicles can play an important role in demand-side management, fuel cell electric vehicles have the potential to operate as highly flexible, dispatchable power plants as they can produce electricity. Fuel cell vehicles are all electric vehicles that are powered using electricity generated on board from gaseous fuel using a fuel cell stack. A small battery is used to store energy with regenerative braking, although it can be designed to have a bigger battery or a smaller fuel cell. The fuel for fuel cell electric vehicles can be natural gas or hydrogen, by the fuel cell vehicles currently being commercialized or under development use hydrogen. The car as power plant concept, investigated at the Delft University of Technology in the Netherlands, proposes an integrated energy and transport system that is based on the use of fuel cell electric vehicles as flexible, dispatchable power plants and the use of hydrogen for storage variable renewable energy sources as an energy carrier. The idea of using electric drive vehicles to provide electricity and services directly to the electricity grid or directly to the energy users was put forward through the concept of vehicle-to-grid power, vehicle-to-grid technology. It can be done by plug-in electric vehicles as well by fuel cell electric vehicles. As mentioned earlier, fuel cell electric vehicles are the only type of electric vehicles that represent a new electricity generation source. Like stationary fuel cell systems, fuel cell electric vehicles can be used to provide electricity when they are in stationary mode. Therefore, fuel cell electric vehicle fleets that are parked can become dispatchable power plants and serve local loads or the electricity grid. Fuel cell power can be then used to replace the power that would be otherwise used from the grid, for example, during peak hours. A single vehicle could power up to 100 households during peak time, while 500 cars could replace an entire power plant. The net revenues from fuel cell electric vehicles-based power are represented by the net saving incurred through the use of fuel cell electric vehicle power instead of the grid power. This type of use of fuel cell vehicle is technically feasible and economically sound under certain circumstances and depends on many factors, including the climate. The potential benefit of realizing and using the system would be achieving a more sustainable passenger transport system and a more flexible electricity system due to the use of electric cars to support it. Whether these benefits can be materialized depends on a large variety of developments in the electric car technology, including fuel cells, the required new refueling and charging infrastructure, the behavior of potential users who need to offer their cars for the vehicle-to-grid system, and introduction of advanced electricity metering system. Irrespective of the benefits of using vehicle-to-grid technology, it remains in its infancy, although the number of pilot projects worldwide is growing. To make vehicle-to-grid possible, incentive and policy measures are needed. Here we think about mandates on subsidies as a way to support this technology directly, and additional incentives, for example, to develop the vehicle-to-grid standardization or to do the fundamental applied research. Also, subsidies for vehicle-to-grid capable cars or chargers can be an important incentive to stimulate the technology adoption and usage. These subsidies are needed to bring costs down and to scale up the individual pilot project to mass adoption level.